Hi, in this video I'm going to introduce you to the three-dimensional coordinate system and give you the formula for the distance between 2 points or the length of a line in 3D. So first, let me show you the difference between 2D and 3D in terms of sketching functions and equations. So say this is 2D over here, 3D over here. So in 2D just have two dimensions. We have the x-axis and the y-axis. In 3D we have three dimensions. This is the x-axis, this is the y-axis, and this is the z-axis. So let's say we want to sketch this equation over here. X squared plus y squared is equal to 4. In 2D we know that this is an equation of a circle of radius 2. So it's just a circle of radius 2. Now how about in 3D? Well, in 3D we have this extra variable here, z. So what's the equation gonna be when z is equal to 0? Well, when z is equal to 0, we're gonna have x squared plus y squared is equal to 4, which is an equation of a circle of radius 2. Okay, what do we have when z is equal to 10? Well, when z is equal to 10, we still have x squared plus y squared is equal to 4. So we also have a circle of radius 2. Same thing happens when z is equal to negative 50. What about when z is equal to negative 0.125? Well, it's still a circle. Eventually we're going to have an infinite number of circles that goes from z equal to negative infinity to z equals positive infinity. And this equation becomes an equation of a cylinder in 3D. So let me redraw this because the other one looks ugly. So if I want to sketch x squared plus y squared is equal to 4 in 3D, keeping in mind this is the x, this is the y, this is the z, it's going to be an infinite cylinder. Like this. Okay, now let's have another example. Let's say we want to sketch x squared plus y squared is equal to 4, and at the same time z is equal to 5. Well, unlike the previous example, we're restricted here. Z has to be equal to 5. Z cannot take any value, it has to be 5. So let's say this is the point where z is equal to 5. Then when z is equal to 5, we have a circle of radius 2. And this distance over here from this point to the origin is equal to 5. And that's it. You're gonna get more familiar with the three-dimensional coordinate system as we move on and as we solve more examples. So don't worry about it if you don't know how to sketch these equations. You're gonna be better at it as we move on in the course. Okay, so the next topic I want to talk about is the distance between 2 points. Just a reminder, I want to remind you of how we used to do it in 2D. So in 2D, let's say you're trying to find the distance between the origin and this point over here, which has the coordinates 3, 2. Trying to find this distance over here. Well, let's call this P1, point P1, this point P2, and the formula said that P1, P2 is equal to 3 minus 0 squared plus 2 minus 0 squared, which is the difference in the x coordinates all squared plus the difference in the y coordinates all squared. And this, where we got this from? Well, we use Pythagoras theorem. This is 3, this is 2, this is a 90-degree angle. So this length over here, let's call it L. L squared is equal to 3 squared plus 2 squared. Therefore, L is equal to square root of 3 squared plus 2 squared. Now we're going to use the same idea in 3D to find the distance between 2 points. So let's have an example over here. This is x, this is y, this is z. And let's say we want to find the distance between the origin and, let's call the origin P1, let's call this point P2, and P2 has the coordinates 3, 4, 5. And let me project this point on the xy plane so you have a better understanding of where it actually is. So this is the projection of the point, and this is the projection of the line, or the shadow of the line on the xy plane. So this point has coordinates 3, 4, 5, which means we move 3 units in the positive x direction. So we move 3 units in this direction. We move 4 units in the y direction, so it's 4 units. And then we move 5 units in the positive z direction. Then we reach the point. The distance we're interested in is, let's call it L, between these 2 points. And to find L, we're going to use Pythagoras theorem twice. First, we're going to use Pythagoras theorem to find this distance d of this line over here. I can say that d squared is equal to 3 squared plus 4 squared, because this is a 90-degree angle. Then I'm going to use Pythagoras theorem one more time to find this distance L. So L is just d squared plus 5 squared, because this is also a 90-degree angle. L squared is equal to d squared plus 5 squared. And d squared is just 3 squared plus 4 squared. Therefore, L squared is just 3 squared plus 4 squared plus 5 squared. And L is square root of this whole thing. So it's the same idea, and actually it's the same formula, except in 3D we have to account for the third variable, the z. So it's the change in the x coordinates, or the difference in the x coordinates squared plus the difference in the y coordinate squared plus the difference in the z coordinate squared. So the general formula, let me write it down for you. For distance between 2 points P1 and P2, let's say P1 has the coordinates x1, y1, z1, and the point P2 has the coordinates x2, y2, z2. Here's the formula. So it's the difference in the x coordinates squared plus the difference in the y coordinates squared plus the difference in the z coordinates squared. And this is the general formula. I hope this helps. If you have any questions, please leave them in the comment section below. I'll be more than happy to answer them. Good luck.